Welcome back to Office Hours with Bill Jennings at Klamath Community College. Let's continue on with our discussion on our Section 2.6 for our purposes. This time I want to talk, though, about these composite functions. So we just did the combinations of functions, or otherwise known as the algebra of function. You take two functions, add, subtract, multiply, or divide them together. Don't overthink them. That's the number one thing. But composite functions, if we want to compose two functions together, we want to take one function and run it through the other. It's a little bit different, and the notation, like I said in our other video, but our notation is going to be right here with a slightly different look, and what you really need to focus on is that kind of looking zero there. So that's F composed with G. And the definition that was going to happen there is we're going to take the function G and run it through the function F. And we can also do it in reverse, where we could take the function F and run it through the function G. And we'll demonstrate, a demonstration is going to be worth everything here on how it actually comes together. What I want you to, for right now, what I want you to pay attention to is that notation, and notice that this is completely different notation than that. Don't get the two things confused. This does not mean G times F. It means G composed with F, which what we're going to do is take F and run it through the function G. Let's go take a look at some examples and make it come together. So what we're going to do here is start with an example, and we'll come back and we're going to talk about the domains later. It's just as important as the algebra functions, but we're going to make it work first, and then we'll come back and deal with the domains. We've got to understand it first. So we're going to create a new function by taking, in this case, F composed with G. We're going to take the function F, and we're going to take G and run it through the function F. So if we were to have two functions that look like this, I have the function F and I have the function G. And when I say I'm going to take the function G and run it through F, I'm basically saying we're going to take this is the definition of G of X, and we're going to plug it through the function F. So you could say what this is really saying is let's find F of 2x squared minus 9, because 2x squared minus 9 is really just the definition of function G, and we're going to take that definition and run it through the function F. So don't make it harder than it is. This is defined as being equals, well, let's put it in hard code, 7 plus 1. This is the function F. This is the function F, because I've got it's a 7 times the input plus 1. And what we're going to input into that function is going to be 2x squared minus 9, because that's who G is. So we're going to take G and we're going to plug it in for every x there is in F. And then now it's a matter of just hanging on to your algebra and simplifying. So this turns into 14x squared minus 63 plus 1. So let's just call it minus 62, and we're done. Don't try and factor it. It is not supposed to be factored. It's just going to be, this is the result. It is not set equal to 0. Do not solve for x. This is F composed with G. I should make that a little bit more visible there. That's the result of F composed with G of X. Now, we talked about it as being, well, if you can take F and run G through it, could you take G and run F through it? So basically what we're going to say there is we're going to take the function F and we're going to plug it into the function G. So the function G, so this is defined as being G of 7x plus 1, because 7x plus 1, maybe I should write that in green, 7x plus 1, because 7x plus 1 is the F function, and we're going to run it through the G function. So here we have it. I've got my G function is defined as being 2 times whatever the input is squared minus 9. And I want you to see that as being this right here. Wherever you had an input, I left a space. And what I'm going to input into that space is the F function. So this is 7x plus 1. All I have left to do now is some algebra. Don't distribute the 2 first, because the squaring order of operations still rules the world. I've got to square it first, then I distribute the 2. So this is going to be 2 times, this is going to be 49x squared plus 14x plus 1 minus 9. And if you had a hard time with this part right there, just take 7x plus 1 and put 2, make it a binomial times itself and FOIL it on out. So then this turns into 98x squared plus 28x. The 2 times the 1 is going to give me 2 minus the 9. In the end, I'm going to get a minus 7. I'm kind of doing that in my head. The common mistake here is then for students to try and set this equal to 0 and try and factor it. This is actually the simplified form of it. Factoring is actually unsimplifying. This is the simplified form of G composed with F. Let's clean that up. Let's make it nice and pretty so we can actually read it and it looks really good. This is the result of G composed with F of X right here. That is your answer, and that's what we're going to have. Now, sometimes this one's actually a pretty complicated one because I had that one going into here. Let's do another example. I've got F composed with G of X. So this is going to be F of X plus 2, and maybe I'll make X plus 2 red. So I'm going to take X plus 2 and run it through the F function. Well, the F function is defined as being the square root of whatever you're trying to stuff into it. Well, what we stuffed into it was X plus 2. We are done. Don't make this a bigger problem than it is. This is the result of F composed with G of X, and we are good. Now this is G of F of X. Well, F of X is the square root of X. Maybe I'll make him green so we can watch him come through. So we're basically saying let's take the function G and we're going to run the function F through it. So we're going to run that guy right through there. So this is, well, the G of X function was whatever your input is and then add it to 2. What are we stuffing through this function? Well, we said we were going to stuff that guy through it, so it's just the square root of 2 plus 2, or square root of X plus 2, sorry, square root of X. That was this guy right here, so square root of X plus 2. That's all there is to it. Let's not make it harder than it is. Let's talk about some domains. So if we had F composed with G of X, and I'm trying to, this one's a little bit more complicated. I've got some fractions going on and some things that I'm going to have to deal with. So let's look at what this means. This function right here says, let's take F and let's run through it. Let's use color. I think the color is helpful to see where things are coming from. This is my G function. I'm saying this is the same thing as F of G of X. I'm going to take the G function, run it through F. So this is F of 3 over X squared. Well, that's going to result in, this is 4 over, and then I need to put whatever comes in here plus 5. And I've left this space right here. That is where my G is going to go, because that's the X variable that's kind of left hanging out there. So what's going to go here is 3 over X squared. Right here is where I've got two things. If the problem says find this, I have a complex fraction I'm going to need to simplify. But right here, right now, is where I need to deal with the domain problems. So what needs to happen here is I need to identify, okay, I cannot ever let, this cannot have X plus 5 cannot be equal to 0, because that will create a 0 denominator. So what really becomes important here, and then also I got this original function here that says X squared cannot be equal to 0, because that's when that wheel is going to come off the bus. Now, the common mistake here is to say, okay, X cannot be equal to negative 5. But X can actually be a negative 5, because when you plug a negative 5 into this function, it will not actually make that go to 0. It's when this produces a negative 5 that things are going to be tough. So we need to focus right here for a quick moment on letting this come together. So right here is where I need to focus, and everything can come together for me. So when I focus on the red, I see a fraction, and I'm going to say that, hey, X squared cannot be equal to 0, which really pretty much just means X cannot be equal to 0. So that's going to be one of my domain restrictions. The other thing that I need to look at is a little bit bigger piece of the pie, which is the whole denominator here that says 3 over X squared plus 5 cannot be equal to 0. So that's when I've got to deal with that just a little bit. Which in this case, because of the square, so to speak, that's never going to really be a problem, because whenever I put a X in, I'm never going to get a negative value out of this. So this has got no troubles, so no trouble. no trouble here. So my only restriction that I'm actually going to have to worry about on this particular problem is x cannot be equal to 0. But I did need to pull this off over here and make sure I checked it so that I was never going to have that be a problem. And the reason why that's not a problem, if I'm skipping a step for you there that's hard to follow, if you put 3 over x squared equals a negative 5, there's no value you could plug in for x that would ever create a negative value on that other side. So we're good to go there. Let's look at one more of these so that we can maybe see another example. So f composed with g, in this case, this is going to be f of g of x. Well, g of x in this case takes on the value of x minus 3. So I'm going to take x minus 3 and I'm going to shove that through the function f. So as a result, this is going to produce the square root of whatever my input value is, and in this case, x minus 3. What is my domain restriction? Well, my domain restriction says x minus 3 has to be greater than or equal to 0, so in this case x has got to be greater than or equal to 3. The common mistake here is to focus up here and say, oh, well, x has got to be bigger than 0. But the end result here is you're not looking at the function f, you're looking at the function f with g run through it. And so there isn't really an x that ever goes there, it's an x minus 3. So we need to kind of ignore the f function and plug it in to get it to this point so we can actually see what the restriction truly is. So this is going to be x is greater than or equal to 3, so we would get an interval notation that looks something like that. Coming down here, if we was to talk about f composed with g, I'm going to have f of, and this is going to be square root of x squared minus 9. That's who's getting run through the function f. The function f is 9 minus whatever my input value is squared. Looking at this value that goes here is x squared minus 9, and now I've got a little square root feature going on here that's going to be important. I was one step ahead of myself. Right here, though, is where we need to identify my domain restrictions, because if I actually simplify this right now, I'm actually going to get the radical to go away and it's going to look like everything works. But at this moment, right here on the initial plug-in, this is where I need to identify what is my domains that work. There's going to be no restrictions on the f function, so to speak, but the g function still has these restrictions that I'm going to be focusing on. X squared minus 9 has got to be greater than or equal to 0, which means that x squared has got to be greater than or equal to 9, which intuitively we can identify that as being I can work with a negative 3 to the left, and I can work with a positive 3 to the right. Might not be something you've seen before, but if I talk about x squared has got to be greater than or equal to 9, I can see that there's a hole in the middle, like 0 isn't going to work, 1 isn't going to work, 2 isn't going to work, but 3 is, and so will negative 3, because when I square it, it's going to come out to be that. So my domain is going to be negative infinity to negative 3, unioned up with 3 to infinity, and that's going to be something that works very well for me. So there we have it. This could be cleaned up now. So now I've got 9 minus x squared minus 9. I better put some brackets there so I hang on to this negative sign. That's going to be very important to me. And so I end up with a negative x squared plus 18 as my final answer. And again, don't solve it. This is the result of f composed with g of x, and even though it looks like there shouldn't be any domain restrictions, that is the domain restrictions, because I have an original function f and an original function g that I need to deal with. Hope you got something out of the video, and we'll catch you next time on More Office Hours.